Hello YouTube! Hey! So today we are about to talk and discuss some fascinating topic. The fascinating topic is the Mersenne prime numbers. Mersenne, if it actually happen to be not aware of it, I'm gonna explain to you right now what is that. So the Mersenne prime numbers are the prime numbers which can be represented in the following way. So 2 to the power of k minus 1. And what those primes are. For example, the 3 is actually a Mersenne prime number because we have that 2 to the power of 2 to squared minus 1 is actually 3. And we have the 7 also satisfy the property. So 2 to the power of 3 minus 1 is actually 7. So, and it keeps going. At the moment, only 51 Mersenne prime numbers are known. If you just go to the Mersenne list of Mersenne prime numbers, it has the official website, mersenne.org, and only 51, oh man, internet, just a little faster. Only 51 numbers are known. The last number was discovered in the 2018, I suppose was that, on December 7th, by Patrick LaRoche. I think I misspelled his name, his surname. I'm sorry, really. So it has 24,862,048 digits. Just imagine this number. So it's like the last number, and he did that on the Prime 95 and Intel i5 4590T with 2 gigahertz, and that's pretty interesting. For example, I have the Pentium G4600, I believe, which is with 3.6 gigahertz of frequency, and yeah, that's exactly how it is, how it actually goes. So it's just off-topic questions, off-topic thing. Now, like, don't pay any attention to it. So we got to actually dissect this thing. It's for if we have some prime numbers, we're gonna actually check if this prime number is potential prime number is actually a Mersenne prime number. And for that matter, we have some primality test, which called Lucas-Lehmer primality test. And we have this algorithm. It is pretty simple. So we start with the initial value of 4, and we keep repeating this, keep the same algorithm k minus 2 number of times. For k is actually the power of this. Just k is actually this. Yeah, it is a power. And we gotta repeat this algorithm exactly k minus 2 number of times to get the actual result, whether the tested prime number, potential prime number, is actually the Mersenne prime number. And how does it go actually? So we have the test of this kind. So we start with a 4, mod it with a 2047. 2047 is actually our prime number, or potential prime number. Then we go ahead and just square this number, and subtract the 2 from it, and we also mod it with 2047. We get a 14. Actually, in 14 it is the next, get passed to the next stage. 14 squared minus 2 mod 2047 is 194. So it's like the pipeline system, and there's a whole pipeline just determines whether the prime number, whether this number is Mersenne prime or not. Yes, exactly how it goes. And we can easily program it, and it only takes about just 6 number of lines. Six lines of code. Like, is pretty simple. First, we gotta assign a number. Gotta assign a 4 to the a and 4 to the temporary variable, which we're actually gonna use a little later. And we're gonna use it. We gotta actually iterate this k minus 2 number of times. I think I've added one because I have some have some suspicion that Python doesn't include this. Correct me if I'm wrong, because I'm not a Python guy. You know, I'm mostly using C++, but I actually decided to do this in Python for the matter of curiosity. You know, so we gotta generate our power. Yeah, our power with the help of power function. We raise the temp value to the second power and subtract 2 from it. So, and then we mod it with the p prime, exactly how we do here. Exactly. And assign a temp to the a. Like I said above. Oh man, like I said before, we gotta actually. It is a pipeline system, so we gotta generate the input for just our output is actually the input for the next stage. So in the end, we gotta check if a is equals to 0. And that's in this case is if a9 or ak minus 2, k minus second is congruent to 0 mod 2k minus 1, which is actually our prime, potential prime. So then we have a method, Mersenne engine, which is responsible for generating Mersenne prime numbers. If I'm allowed to say like this. So for that matter, we created primes, the empty list of primes. It doesn't contain anything for now. Then we're gonna append the 3. So I'm doing it for the matter that our primality test is Mersenne prime. Lucas-Lehmer primality. Mersenne primality test fails for the value 3. So correct me if I'm wrong, but I've actually tested this on 3 and it actually fails. So, and we do this n number of times, which you gotta pass in here. I just passed it 107 because when I actually was looking at the sequence of numbers, I wanted to get the 11 prime Mersenne prime numbers. Yeah, 11 is also the prime number. So in the power of this number is 107. So I did this on purpose. And we do this right here. So 2 shift left shift I. What is that? What is that actually? It is the same thing like the power of 2 to the I. Just, yeah, exactly. The left shift is equivalent to this. You can read about it. It's this binary arithmetic is pretty fascinating, and you gotta know about it a lot. I just don't know about it just much, but I do love it. I do love it. So, in its to the power of, I'm gonna translate it into the mathematical language. So to the power of I minus 1. So we're checking the first number. For example, if I equals to 2, yeah, we gotta check if 2 squared minus 1 does equal to 3, and we gotta actually check if this number is a prime. We pass the prime, the p, which is a 3, and its power, and we actually, if it is prime, happens to be prime, Mersenne prime, we gotta append this in our list. So, and populate our list by this way. Then we have a def main, which since our Mersenne engine returns a list of values, we gotta actually assign a output of this Mersenne engine to some variable, which is in this case is a list. So Python has some typeless variables. You can do that. You just can't do this in C++. You can do this like auto thing, and it makes this trick. But in Python, you can do this like easily. So you just don't have to specify the type. So, and we have primes. We assign the primes. We assign the list of values to the prime. We assign the output of this Mersenne engine to the primes list, and print this list. Yeah, exactly what we're doing. So, and if we actually, I've already run this before. I'm gonna do this again. MSN primes, if I'm not mistaken. Yeah. So we have 11 first primes, which is right here. So that was the video. So thank you very much for watching, and really appreciate this. So thank you very much, and goodbye. Goodbye, my friends.